The Institut de Neurosciences de la Timone is located in the Medical Faculty campus in Marseille, near the prestigious hospital La Timone. Our story begins in 2012, when a group of talented researchers from various institutes combined their efforts to open the Institut de Neurosciences de la Timone, a brand new building, 4,500 square meters in the center of Marseille, dedicated to developing high-level integrative neuroscience research, from cellular approaches to cognitive neuroscience, from various animal models to human and patients, linking scales and models through computation. Currently, the INT hosts 13 teams and 6 platforms at the cutting edge of technology, gathering approximately 180 people from all over the world to this institute, specially designed and built to boost interactions between research teams. Come on in, let's take a look inside. The strength of the INT is its focus on a limited amount of nervous system functions: motor, sensory perception, emotion, and motivation, with multi-level approaches. Thanks to neurobiology, integrative and cognitive neuroscience, computation, and a continuum of models, rodents, non-human primates, and humans, INT is able to uncover both normal and pathological brain functioning. Recently, a new photonic imaging center was created to develop and use cutting-edge photonic tools for the anatomical and functional exploration of the central nervous system at multiple spatiotemporal scales and fields of views, on multiple preparations and models, from in vitro to in vivo, from rodent to non-human primates, and with wild-type and genetically modified animals. For example, some researchers are working on rodent models to study the functional organization of spinal cord neurons during both physiological and pathological development. The NeuroBioTools platform aims to support the development of novel and innovative technologies. One of its missions is to propose vector development and production services especially designed for neuroscientists. Here in the MRI Center, macroscopic datasets are acquired across animal models. Neural bases of social cognition, such as voice perception or emotional processing, are studied in both human and non-human primates. Most importantly, exceptional computational research is conducted in the center, using 3D brain surface pictures and MRI to study the development of cortical folding before birth, but also to link all MRI data acquired across many different primate models. As you can see, there are many notable non-human primate research projects at the INT, making the INT a unique research center in the area. This is thanks to the creation of MPRC. Some of our researchers are using new techniques such as kin-arm exoskeletons and multi-electrode arrays in the non-human primate to understand brain processes underlying motor control of the hand and processing of visual information at multiple cortical levels. Similar approaches are also used to understand how these brain processes are used to program and control eye movements and how the prefrontal and posterior parietal cortex interact with sensory brain regions to guide the selection of sensory information for making appropriate decisions. In another example of the INT's dedication to translational research, clinicians and researchers working with rodents, non-human primates, and Parkinsonian patients try to better understand how the basal ganglia is involved in motivational processes and reward-related behaviors, in physiological or pathological conditions such as addiction or impulsive disorder. Such a strong link between researchers and clinicians, psychiatrists, neurologists, and ophthalmologists is reinforced through the development of several experimental setups, such as MRI and eye tracking setups, shared with the local clinical units, hereby facilitating the exchange between researchers and clinicians. Et voilà! Le Institut de Neurosciences de la Timone welcomes you to visit us in Marseille, and you can look for us at the FENS Forum in Paris. Bye-bye!